go check out, you know what? Problem of the day. Solve the equation. 5x minus 15 equals 15 minus a 5x. So we've got it looks like, boy, a lot of those 5s and 15s up there, they can get a little confusing when you see all those different things. Let's see, 5x minus 15 on one side. Write that down at home, folks. 15 minus 5x on the other side. Let's see how we're going to work through this problem and make sure we don't make any, careless mistakes. I already see somebody saying, well, Ernie, there's a negative 5 here and a positive 5 over there. Those are going to cancel. Well, no, they're not. And let's see why. Because we got an equals in between them. So let's take this problem. I'm going to rewrite it down here. Now, like I said, most of you all have already written it home. Let's check it out and see where it's going to go. And on the other side of the picture, we've got 15 minus 5x. And as always, we're going to check that solution, which will make us know for a fact that we did it right. Correct? Everybody good? Now, let's figure it out. First of all, I mentioned something about this minus 5x. Don't add it to that 5x. Guess what? They'll disappear. Now, that can happen, but you don't want it to happen here, all right? So let's add 5x to both sides instead, because that's how we're going to remove this minus 5x off this side. So add 5x over here, because once again, we balance both sides. You got to do it to the right, you got to do it to the left, all right? You got to balance them out. And in this case, we're going to end up with, looks like not a wipeout, but a 10x comes up instead. And we got a minus 15 hanging on, and we got a 15 sitting there. Now, someone's already saying, well, is that going to give you 0? No, it isn't. It's going to be the same game we did with the 5x here. We're going to add 15 to both sides here, because that's how we remove a subtraction. It's how we unwind the process, actually. So let's put it over here. We'll add 15, and it's looking better and better. I'm seeing 10x equaling to, not 0, but 30. Got 30 going there. And divide both sides by 10. We call those the properties of equality. By the way, those were addition properties of equality. It got us where we are. Now we're going to do division, because we're going to divide both sides by 10. And it looks to me like, what are we going to have here? We're going to have x equaling to a 3. Now, what do we do with that 3? We hope it's good. We hope it's a good answer. Is that true? That true? Let's go back and figure out what we end up getting here, all right? And this could be an interesting answer when we check. Let's see how it balances out. So let's go back over here and put our 5x minus 15 equals to 15 minus the 5x. And we're going to put a 3 in everywhere we see an x. So here we go, 5 times 3. And we're going to subtract 15 this way. On this side, we're going to take 15 minus 5 times 3 once again. Now notice, it does look like we're going to get the same value. We hope to, right? Because that's how we know we worked. The problem worked. Let's see what happens. I get 15 minus 15. That makes some of us nervous. But over here, I get 15 minus 15 also. So I've got 0 equaling 0. Pretty cool. It does check. It does check. And again, just watch your signs. Now, some of you are asking me, what would happen if we thought x equaled 0? Remember I said something about whether we'd gotten a 0 here? If we had had a 0, when we put it back in up here, that's the whole point of checking. If we'd had a 0, we would have had 0 minus 15, which gives us negative 15. Over here, we'd had 15 minus 0, which gives us positive 15. So that's how we would know the problem, the number we'd chosen if we'd gotten a 0, would not be the one we want to use. As it turned out, 3 worked great. It checks. It checks. There you go. Problem of the day pretty much solved out. And again, watch out for those careless mistakes, because you got to remember, change your sign when you send it to the other side in an addition or in the subtraction mode. That's where we started.